last part of chapter 18, we're going to be looking at using permutations and combinations in our probability calculations, as well as something called Bayes' theorem, which has a massive use in artificial intelligence. So, permutations, remember those involve orders, and combinations involve groups. You have to weigh your options when you come to a probability problem on which one you might need to use. So we have a squad of 13. There are 4 brothers on that squad, and we need to put together a team of 7. Find the probability of having at least 2 brothers. First, let's dig out at least 2 brothers. What does that mean? 2 or 3 or 4. Now our total probability, our total things possible, there are 13 people, and from those 13, I need to put them into groups of 7. And because things together. Well, how many ways can we get 2 brothers on this team? That means of those 4, we're going to choose 2. But we also have a group of people, 9 of them, where I'm going to have to select 5 people. We've selected 5 from the 9 non-brothers, 2 from the brothers. The way those can happen together, we multiply them. Total of 7 people. Or we could choose 3 brothers. So 4 choose 3. Now of the 9 non-brothers, we can only choose 4. And finally, we could have 3 picks from the 9. And doing this calculation, we get approximately 0.783. We have 5 letters. What's the probability that if we randomly place them in a row, we get the word units? Well, this is clearly an ordering problem. And there's only one correct way to put these letters in order out of a total of 5 factorial ways that we can write the letters down. 5 objects, putting them all in order. One correct way of doing it, we get a probability of 1 out of 120. And now Bayes' theorem. It has to do with conditional probability. Probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B. What we're doing here is sort of making an inference. We want to know, well, we'll look at an example. And the bottom part of this is the total probability of getting B. And essentially we're looking at B as being a second event that occurs. What's the probability that A happened, given we know the outcome of the second thing? So the ways that B could happen is B could happen given that A happened first, or B could happen given that A didn't happen first. And we got to add those things together. It's called the total probability of B. And hopefully you can imagine that there's a lot of different ways that this could be used in artificial intelligence. We want to know, okay, so this happened. What's the probability that something else happens? We want to be able to predict outcomes. So we're going to look at a problem. We have a can that contains 4 blue and 2 green marbles. 2 marbles are drawn without replacement. Find the probability that the second marble is blue. Okay, one thing that we could do is, and I'm going to call A, just to stick with the notation that we used a second ago, A is going to be that the first marble is blue. Event B is going to correspond to the second being blue. You can use whatever letters you want here. I'm just using it so I can use the formula from the previous page a little easier with you. So on the first draw, either it's blue or it's not blue. And then we're going to draw again. And for the second event, it's either blue or not blue. Easy enough. Now let's assign probabilities to these branches. The probability that the first marble is blue is 4 out of 6. Probability that it's not blue is 2 out of 6. Now in the second draw, something's already happened. So the probability that it's blue on the second draw, there's only 3 blue ones left out of 5 total marbles. The probability of not getting blue on the second pick, there are 2 non-blues in there out of 5. You should be putting 4/5 because we didn't pick a blue one on the first one, and 1/5 on the second branch. So the probability that the second marble is blue. Let's walk down this path to those. Follow that branch, or follow here, is we're finding, and we're doing 4/6 times 3/5, that's the top branch, or we could take the bottom branch, 2/6 times 4/5. And that is we've taken the probability of A times the probability of B given that A occurred, that's the 3/5, plus 2/6 is the probability of not A times the probability of B occurring given not A. And that's his bottom path. 4/5 is only 4/5 because we didn't pick a blue one first. So that's the bottom part here. It's the total probability that B occurs. The second event occurs. Now the question I'm going to ask is, what's the probability that the first marble, that the second one is blue? That the second marble was blue, now look back and say, okay, what's the probability that the first one was green? So we're wondering here, what's the probability of not A given B? Well, according to Bayes' theorem, that's the same thing as taking the probability of B given not A times the probability of not A divided by the probability of B. Well, we found the probability of B right here, it's 2/3. We can easily find probability of B given not A, that's this bottom branch here. B given not A is 4/5 times the probability of not A, that's 2/6. This is equal, when we calculate it out, to be 2/5. So, there's an application of Bayes' theorem. There are some more intuitive ways to sort through a problem like this, sometimes, but in the field of artificial intelligence, rarely is something this simple. These problems can get quite big.